ハロー。で、カメラをこれにしないといけないのか。
マイクとカメラを撮ります。これはだから
スピーカーがミュートになってます。
カメラ。一個移動する。
ねえ、なんかダメかも。カメラさ、私が映る。あ、これが消えた。さっきまでついてたよ。これ。なんかね、ここがね、悪いんだよね、多分。なんでこれ青くなっちゃうの？そんなことしてるこの前、左声が聞こえなかった。これ取れてた。
ドレスの小さじゃないですか。
これが、
壊れてないか気になる。先生お願いします。
はいはい。
見てますか？なんかでも反応が。
Can you hear?
So Taiwan side, can you hear my voice?
Yeah, we can hear your voice.
Okay, thank you.
Yeah, we can
Thank
hear.
you.
Thank you.
Can you see my slide?
We can see your slide. Thank you.
Okay.
あげます。
人数多いんだ。なんでそこに知ったか多いの？
あ、そっか。
もういいのかな？
これで、時間が20分からです。
今21分ぐらい。
じゃあ、録画を始めます。大丈夫です。お願いします。
Okay. So let's start today's lecture. So food safety control and quality evaluation. So my name is Utsumi, and I'm belonging the College of the Agro-Resource Sciences. 止まったじゃん。ちょっと待って。Okay. At first, I introduce myself briefly. So I'm professor of Faculty of Life and Environmental Sciences, University of Tsukuba. And I saw the several students already took several of my lectures. And my study field is basically aquatic eco-engineering and microbiology. And also especially environmental microbiology or microbiology technology, we call it. So related to the microorganisms, and today's lecture may focus on the food, but my main target is not food, so water. So today I introduce you the several very important topics for water, and also the food related to microorganisms. And my study topics is microbial processes related to the biodegradation of contaminants in aquatic environments, such as chemical hazards, such as organic matters, such as toxins, by producing some microorganisms. Also, the second study topics is quantify the bioavailability of dissolved organic matters, such as DOC, methane, and so on. Now, my main concern is methane, because one of the most important greenhouse なんかリレーしてる。Taiwan side? No. Can you hear my voice? Taiwan side? Okay, thank you. So third topic is bacterial production and community structure at the Arctic Ocean. So unfortunately now I cannot go Arctic Ocean, but before 10 years ago, I went to several times to the Arctic Ocean and joined some cruise service and collect not only the water, but also the sediment and measure the environmental factors and the dissolved gases, also the microbial community. But the different, like the surface and the middle layers and the bottom layers. But not today's topics. So today, I want to introduce you some very briefly water properties, also the microbial problem for food. So at first, I will introduce you what is water. So I think already everybody knows water. Everybody drink water every day. So, but water is essential for life. I think everybody agree. So you can live for 40 days without food, but just 5 days without water. At least 20 liters a day per one person. So water should require every day. That one important point. And the amount of fresh water on Earth is limited. Its quality is under constant pressure. And this problem related to food problems. Preserving the quality of fresh water is important for the drinking water supply, food production, and recreational water use. Water quality can be compromised by the presence of infectious agents, toxic chemicals, and radiological hazards. And another important point is here. So water is one of the most important country resources. So if there are no water, it's impossible to maintain the country, especially fresh water. Fresh water requires all countries. If the country government want to manage the country, that point is very important. So we should manage, especially the fresh water. That's very important point. And this point already mentioned some global leaders last century. So first one is Islam Sergezan, who is the World Bank Vice President. He mentioned if the wars of this century, he mentioned last century, that means the 20th century, were fought over oil. The war of the next century, this century, 21st century, will be fought over water. Unless we change our approach to managing this precious and vital resource. And the other world leaders, President Ghali, who is the United Nations Secretary General. He also mentions the next war in the Middle East will be fought over water, not politics. So I think you already know, like the Islam IS groups fought it over. Yeah, of course, politics, but the basic problem is water. So they try to get at the land close to the river. That means getting fresh water. So this kind of information already told some world leaders. Why? So this table shows total amount of global water. So total global water amount is about 1.4 times 10 powers 9 cubic kilometers. I don't know, so huge amount. Yeah, but almost all is seawater. So 97.5% is seawater. So we cannot use directly. We cannot drink directly. And this blue color showing fresh water. Fresh water basically ice. Ice 1.76% of total global waters. And the next one is groundwater. So deep groundwater. It's very difficult to use by humans easily. So this percentage is 0.76%. So that means almost all water on Earth we cannot use directly. So this side, right side showing rate in fresh waters. So you can see about 70% is ice or glacier. Basically ice. And also the groundwater. So 30%. Yeah, you can calculate easily. These two columns plus how many? Almost 99.6% of fresh water we cannot use directly. So very small amount of soil water or the lake or rivers we can use directly. So image. So here is one PET bottle and the amount 500 milliliters. If this PET bottle is total amount of global waters, how milliliters of fresh water we can use? So calculate or image. So the answer is only one drop. One drop of the water is fresh water of the global waters amount. So only one drop. So fresh water is very, very limited resources. So how we recycle or renew the waters in natural situations? Yeah, I think you can know making distilled water. So just boiling the tap water and then gather the vapors. But on the Earth, naturally, only rainfall can reproduce fresh water. So if the water, liquid water, vapor, only the just water, not including some chemicals or organic matters and so on. So only the water vapor. So this cycling is very, very important on global water cycling, refreshing or the renewal. But unfortunately, annual rainfall on the Earth is very, very small amount, just 34,000 cubic kilometers. So this amount is 0.003% of total global water amount. So very few amount only recycling, renewal the water on the Earth every year. And I think you can imagine. So here is the rainfall, not only the land, almost all is in the sea, ocean. In that case, we cannot use. So that also very problems. And please know this ratio. So list of water that man use. We use first sections. So like as your daily life, I think you drink and you use cooking. Also you take a bath, so using the water. But this kind of house and regional society use, it's not so much. So about 10%. Of course, it depends on country situations. So the agricultural main or the industrial main or some kind of sightseeing or something. So it's different. But like this 10% is ARPIN 25 or something, not ARPIN 50%. And industrial use, so average 20 to 25%. So main part of fresh water using agriculture, irrigation use. So this percentage is more than half. So 65 to 75% using. So fresh water for man use is mainly agriculture. So please remember this information. And here, so demand and use of fresh water has tripled over the past half century, as world population has grown from 2.5 to 7 billion. But this description wrong. Did you read this morning newspaper or last night news? How's world population? Yeah. So now, not 7, 8 billion。80億人ですね。ニュースでやってますね。見てますか？ So please check every day newspaper or news. So not 7 billion, now 8 billion. One population. And experts predict that by 2025, global water needs will increase with 40%, more required for cities, and 20% for growing crops. That means agriculture. Of course, human population increasing, and many people gather the urban city regions. So need or require fresh water. And also population increase. That means we should produce crops. So according to the UNESCO estimate, by 2030, global demand for fresh water will exceed the supply with potentially disastrous consequences. And over the next 20 years, average water supply per person is estimated to drop by a third, endangering human health, agriculture, and environment. So now the water is like facing very severe problems, many severe problems. I will inform you. So this is fresh water use country profiles. So please find out your mother countries. For example, in Japan, this like the bright orange or something here. So agriculture widely dominant, with significant use by the industrial sector. So same as like the China. Also, for example, some Asian countries is green. So this means agriculture widely dominant. And European countries, so pink. So industry widely dominant. But of course, the main part is agriculture. Okay. So not like this pink in showing or the meaning. Industry part has more than 50%. This is wrong. So percentage of the industry part is a little bit high, like the 30% or something. So but mainly using agriculture. So like the green one, that means the agriculture part is about 70% or the 80%. Okay, so don't misunderstand these figures. So what we call 21st century. So we call sometimes the 21st century has been called as the century of water. So now I have a question for you. What do we call 20th century? Last century. How or what do we call? Century 4? Why? Oil. Yeah. Other answer? Several answer. Yeah, oil is one answer. One of the answer.さあ、20世紀は何なんですか？ how we call 20th century. So one answer is oil century. Yeah, I agree. Taiwan side, is there anyone have some answer? No? So, one of the answer, war. Other answer, such as science and technology. Yeah, we have several another answers, but oil, war, or science and technology is very dominant opinion. How we call last century. Also I introduce you. So this century, we sometimes call century of water. But I think other, how we call this century? What we call century of biology? biology までいくかな。いや。Microbiology? Yeah, I hope. I hope. そうね。例えば、such as ITO. Like as IT or the PC or something. Yeah. Or in the near future, like the virtual something or something. I'm not sure. So you can create how we call this century. But anyway, so why we called century of water? Yeah, because a serious water problem confronting human life. So two problems. One is water shortage. So 2 billion people are facing water shortage. And 1 billion people lack access to safe water. And second problem is water contamination or the pollution. So 3.6 million people die each year from water-related diseases. 43% of deaths are due to diarrhea. And 2.5 billion people lack access to improved sanitation. That also very severe problems. So I will show some map. So this map or this graph showing total population access to an improved water source. So this column showing access to an improved water source in percentage of total population. This data are not so recent one, but so please capture your mother country's situation or those country's situation. So this deep blue color is more than 95%. So like including Japan. But like the yellow and orange color is not so many people can access improved water source. So many countries still, many country people still difficult to get or take improved water source. And second graph showing total population access to sanitation. That means like the water toilet systems or separately the liquid phase and solid phase. So you can see almost all countries cannot access to sanitation. So red one is more than 50% cannot access sanitation. And the orange one is from 31 to 50%. So almost all African country, South American country, and Asian country still don't have good sanitation systems. So underwater, subwater treatment systems, treatment facilities doesn't have. So this situation is not good for humans' health. So I will show the one information. So this graph, left side, showing percentage of population with access to safe drinking water. Okay, so such as the USA, almost 100% people can access to safe drinking water. And like the Cambodia, only the 20% people can access safe drinking water. And the right side, graph showing deaths of children under 5 years old. So, completely opposite phenomenon. So, high percentage of access to safe drinking water. So, children death small. But a very small number of the people can access to safe drinking water. So children death is large numbers. So that means supply safe drinking water is very important. Very, very important. Yeah, this lecture is related to food. But at first, you should consider water situation. Safe water supply is most important. Then, food. This is my opinion. Yeah. But water supply, safe water supply is very, very important. So if we cannot supply safe water, so some people catch like the not good bacteria from the water and diarrhea. Then take some other diseases. So safe drinking water is most important. This is my opinion. And now, we faced more severe problems related global warming and globalism, people moving, or the people transport. So this is the one example. The spread of cholera from 1950 to 2004. So cholera is like the domestic disease. The 1950 to the 1960. But after that, so globalism or the globalization, so many people can move worldwide. And also, so you can see the these regions, basically tropical regions. That means cholera bacteria is like a tropical species, need high temperature to grow. So if the global warming doesn't occur, like the north part or south part, it's impossible to survive cholera bacteria. But unfortunately, so the global warming and average temperature, also the civilizations gather people in city areas and using the so huge amount of the heat. So water temperature increasing, especially the urban regions. Then, now, cholera spread worldwide. For example, in Tokyo, there are some cholera patients happen, but that patient never go to abroad. So that means cholera bacteria survive and grows in the Tokyo region. Not only Tokyo region, I think. All the, in Japan, the cholera bacteria can survive or live. So I want to change topics. So related bacteria or the microorganisms and food. So at first, I will introduce you characteristics of life and organisms. So, did you think what is life? Did you think what is organisms? This question is very deep. Very, very. 日本人の人も生命って何かって考えたことあります？何が他と変わるんですかね？ What is the difference? Like some matter, organic matters and organisms. This question is very, very deep. Deep question. And more than 200 or 300 years, many scientists, especially the biologists, think, deeply think. So now, these three characteristics, it's like other organisms or life. So first one is it has a membrane system that clearly distinguishes the outside from the inside of the cell. So having membrane. Second one, it has a potential for self-renewal. So that means having gene. And third one, it has a system that takes in substances from the outside and metabolizes them. So having metabolism. So having these three properties, it's life or organisms. One definition. So then, they are closely related to today's lectures. How do you think virus is organisms? No? Oh, I know. Pardon? but virus doesn't not the life organism. How do you think? So virus. Have membrane. Is it okay? Okay ですね。Okay? So virus has gene. Is it okay? いいですか？基本的には DNA か RNA だからね。Okay? So, third one, virus have metabolism. How do you think? So, yeah, virus doesn't have metabolism. They attach DNAs, genes, and then reproduce virus genes and spread. So this does not metabolize. So from the biological view, virus is not like basically, but especially the food poisoning agents. Yeah, you know the virus problems. And now like as organisms, same as the organisms, especially the food poisoning regions, treated virus. But from the biological part, viewing, the virus is not organisms. So what is the microorganisms? So basically, organisms that can be seen only with the aid of microscope, and that typically consist of only a single cell. Microorganisms include bacteria, protozoa, and certain algae and fungi. It may contain a virus. And they are distributed all over Earth, from the crust to the space. So classification by nature of microorganisms. Basically, two types. I think if you learn biology, basic biology, you already know this information. So first one is eukaryotic microorganisms. In Japanese, 真核微生物. So organisms consisting of cell or cells in which that genetic material is DNA in the form of chromosomes, contained with a distinct nucleus. Eukaryotes include all living organisms, other than bacteria and archaea. Second category is prokaryotes, prokaryotic microorganisms. In Japanese, 原核微生物. So a microscopic single cell organisms, which has neither a distinct nucleus with a membrane nor other specialized organisms, including bacteria and cyanobacteria. Written here are the run archaea. Okay. So did run or here domain. Okay. So the living organisms, we can categorize three domains. Bacteria, eukaryote, and archaea. Also, I think you run kingdom, 5 kingdoms. Fauna, like the plants, fungi, and animals, and protists. So 5 kingdom is lower categories of the domain. So domain is the top category of the organism characteristics. And this is new, not the newest. I think this is Science 1999. So these authors present this file tree. So that means many places on the earth own organisms and closely exchange genes. And finally, categorize bacteria, eukaryote, and archaea. So every age, many gene change occur in the environment. So this is newest but the recent trajectory. So characteristics of microorganisms. I pointed out 3 characteristics. So first one is fast growth. For example, E. coli can divide 20 minutes if the environment is comfortable for E. coli. So please calculate. If the after 8 hours, so they can divide 24. That means 24 hours. So that means 2.7 times 10 powers 7 cells. So, question. If 3 days, E. coli can divide as growth, how many cells? Three days, how many cells? And how many weight? How many volumes? Three days or 1 week. Continuously E. coli growing up, growth. How many cells or how many volumes and how many weight? Can you imagine? So all the surface of the earth is E. coli.
5 times 10 over 60.
Yeah. So huge amount. So all the surface on the earth covered by E. Not very thin layer. So thickly covered by E. So this situation is true or not? Not true. Yeah, because we don't never see that huge amount of the E. coli. Why?
Microorganisms have a stationary stage. So it's not gonna grow forever. It's gonna be like a stage of the stationary, and then they go into the death period.
Mm-hmm. Yeah, that one answers. But the most important point is, so growing fast, but die also fast. They are not survival lived, like as a 2 day or 3 days. So growth and divided so many, but died so many. That point is very important. Second characteristic is decompose various substances. I think in this field, food poisoning, yeah, related to the food. That means basically the organic matters. But microorganisms can decompose and degrade, such as a gas, nitrogen gas, or the methane gas, or the, even though the synthetic chemicals, such as a DDT, and recently, so the Japanese scientists find out PET can decompose bacteria from the Osaka prefectures. So basically, microorganisms can decompose almost all everything. At first, microorganisms cannot decompose, but take some year or something. Some microorganisms have the tolerant characteristics for to decompose such kind of chemicals. So third characteristic is live in various environments. So soil, fresh water, seawater, hot spring, seafloor, permafrost, and crust. So everywhere, in your face, in your hand, yeah, living some microorganisms every day. So the most fastest bacteria growing up, dividing. Bacteria is not equalized. Vibrio. So if the environment condition is comfortable for Vibrio, they can divide each 10 minutes. This species is fastest. But so you can calculate. So if the 4 hours not dying, so total cell number is 16 million, more than 16 million. This information is very important for food poisoning. So many bacteria can growth very short period or short time. So if you buy sandwich or rice bowl in the morning, hammer, and then keep it in the car at noon or the afternoon, and then, okay, I forgot eat rice bowl or the sandwich. Yeah, you can easily. Yeah, so basically, bacteria growing up very fast. So please, this characteristics remember. これ何までやんだっけ？
休憩前、4時半ぐらいの休憩。
4時半ぐらい。じゃあまあもうちょっとだね。So, the role of microorganisms. The properties of microorganisms vary widely depending on each species. And the most important role that microorganisms play in nature is decomposition. I've already told you. And dead plants and animals. Excrementous materials and so on are decomposed by microorganisms. And finally, become carbon dioxide, CO2, water, and inorganic matters, such as nitrogen and phosphate, and so on. And the ecological system on the Earth is established only when this microorganism works. So if all the microorganisms doesn't work, already Earth surface covered so many waste. If there are no decomposing, many waste covered Earth surface. But microorganisms do decomposition. So Earth's surface is basically very clean. And considering ecosystems, so we can classify the living things. So first one is producer. We call otto. In Japanese, 独立英. So autotroph is an organism capable of synthesizing its own food from inorganic substances using light or chemical energy. For example, plant phytoplankton, algae. It's these groups. And second one is consumer. So we call heterotroph. So an organism that cannot synthesize its own food and is dependent upon complex organic substances for nutrition. And third one is, basically the consumer, but different. Decomposer, also heterotroph, and this belonging bacteria and fungi. Organisms in a community, such as the bacterium and fungus, that breaks down dead tissues in enabling the constituents to the recycled to the environment. So these three players worked hard and keeping us for the ecosystems. So how many cell numbers in the environment for the food? This is the one example. For example, the normal soil having 10 power 3 to 10 power 8 cells, microorganisms, per 1 gram soil. And the seawater, 1 milliliter, including 10 power 3 to 10 power 6 cells. And air. So, for example, this is having microorganisms. So air includes having 10 powers 2 to 10 powers 5 cells per square cubic meters. For example, food, 0 to 10 powers 7 cells per 1 gram. So why 0? Others doesn't have 0. 0 means no bacteria, no organisms in the food. Why? Why this situation occurs?
The food you're seeing is processed already, so the industry should be sure that we didn't have the microorganisms at the beginning.
Yeah. So we can do like the sterilizations. So all the microorganisms can kill. After that, that food doesn't live microorganisms at all. So we can get this 0 situation in food. So such as the sashimi, I hope the foreign students try and so they like or the favorite food when you back to your mother countries. I hope. But sashimi include having some bacteria. Yeah, but basically doesn't matter. No problem. And so high cell number, sometimes spice. Yeah, spice have many microorganisms. And of course, brown rice, genmai, brown rice have many bacteria on the surface of the rice. So this cell number average like the 10 power 6, 10 power 4 to 10 power 8 cells per 1 unit, 1 gram or 1 milliliter or something. So that means every cell microorganism live. It's impossible to separate from us. Yeah, that's very important. We live together. Okay. So that sense is very important. Every field, living microorganisms stay, live. So, Harman's rules. He said, the microorganism is always right. Microorganism is your friend. Microorganisms are sensitive particles. There are no stupid microorganisms. The microorganisms can do anything. Will do anything. Microorganisms are smarter than chemists, wiser than engineers, more energetic than chemists or engineers. So if you take care of your microbial friends, then we'll take care of your future and you will live happily ever after. You agree? And also the very famous biologist Carl R. Wood they mentioned it is essential that microbiology be perceived and practiced in a way consistent with the natural order of things. Microbes are the base for and sustain all other life on this planet. Let us reorganize all of biology around microbiology. So microbiology or microorganism is main organisms on Earth. So we should learn microorganisms. It's very, very important. So now the almost the time, first class finished. 15分 ?10 分 ?15 分. So 15 minutes resting time. So the next class will be start 4:45 in Japan time. Taiwan side, okay? Yeah, okay. So have a rest.
No, no worries. I don't want to play your game.
I want to see.
No.
いいよ。じゃあ始めますかね。So, let's start the class. So, yeah. なんだろうね。スピードアップしないとちょっと間に合わないんでしょう。the speed up. So, I introduce you some of the factors very important for microorganism growth. So, first one is temperature. Temperature is optimum temperature for growth depends on the bacterial species. That one important information. And several technical terms I introduce you. So in this case, so cyclophilic, mesophilic, and thermophilics. So this is technical terms for microbiology. But please remember these three words. So optimum growth temperature is about 20 degrees Celsius. We call cyclophilic bacteria. 35 degrees Celsius, we call mesophilic bacteria. And 55 degrees Celsius, thermophilic bacteria. If 75 or 80 degrees Celsius, hyperthermophilic or superthermophilic bacteria. So pathogens related to our human beings are mostly mesophilic. So optimum temperature is about 35 degrees Celsius because human body temperature around 75 to 70, around 35 to 37 degrees Celsius. So basically, related mesophilic bacteria is pathogen. And the optimum growth temperature of fungi and yeast is around 25 degrees Celsius, a little bit lower than the mesophilic bacteria. So this also the important point of the temperature. And the most important environment factor is temperature for microorganisms. Please remember this information. So the minimum growth temperature of microorganisms in food is minus 11 degrees Celsius. That means in the frozen, keeping 0 degrees Celsius, it's impossible to kill bacteria. Some bacteria can grow. And the fungi and minus 10 degrees for yeast. So that basically you considered bacteria and fungi. Most human pathogens are mesophilic bacteria because mesophilic bacteria's optimum growth temperature is around 35 to 37 degrees Celsius. And pathogens it's very little growth at temperature below 5 degrees Celsius. So that means it's very useful for keeping food under refrigerators, or the keeping under 5 degrees Celsius. Close to the 0 degrees Celsius is more better. The maximum growth temperature is about 50 degrees Celsius for bacteria. It's not including the thermophilic or the hyperthermophilic bacteria. Basically, cyclophilic or the mesophilic bacteria, it's very difficult to grow over 50 degrees Celsius. And plus 10 degrees Celsius, such as 60 degrees Celsius for fungi and yeast. So that means if you want killing bacteria or the fungi or yeast in the food, you heat food. Yeah, that's one very useful step or the method for killing bacteria or the microorganisms. Bacteria die slowly in the frozen state, but they can survive for quite a long time. So basically it's impossible to killing bacteria, keeping minus several 10 or 20 degrees Celsius. They just like the sleep. And gradually, slowly, they die, but require long time. So don't remember, keeping the minus degrees Celsius, just stopping growth of bacteria. They survive, they live. That one important information. Second, environment factors, pH. But pH basically doesn't matter in the natural environment because freshwater environment, basically pH is very stable, around 7, and in the marine sea waters, basically 7.8. So not so largely changed. But in the food, so rapidly changed pH. So pH is also one important environment factor, microorganism, even the food or the food poisoning. So generally, the optimum growth pH of bacteria is 6.5 to 8.0. That means almost natural, neutral pH values. Bacteria are hard to grow when pH fall below 4.5. So acidic condition, it's very difficult to grow normal bacteria. But some bacteria can grow. Acidophilic bacteria can grow. There are some expressions that can grow even in the acidic condition, such as lactic acid bacteria and others that can grow well at pH 8.0 to 9.0, like Vibrio. So both sides, basically the natural, around 7, is a better conditions for normal bacteria. But acidic condition, like some bacteria, and the alkaline condition, also some bacteria. The optimum growth pH of fungi and yeast is 5.0 to 6.0. That means shifted slightly acidic condition, fungi and yeast. It can grow even under more acidic conditions. And the growth of microorganisms is strongly affected by the pH of the medium. Medium that replaced like the food. So food pH also very effective for microorganisms. And each microorganism has the optimal pH for growth. So for example, bacteria, Actinomyces, or other bacteria, optimal pH is like the natural or neutral pH conditions. And below pH 5.0, they cannot grow, but not extinct, so not die. They can tolerate, bear under low pH conditions. And fungi and yeast is optimum pH 4.0 to 5.0, more acidic conditions. And exception, so some plasma can grow below pH 1. So very strong acidic condition. This species can grow rapidly. They are comfortable for this pH 1 condition. And alkalophilic bacteria optimum pH is around 10. So more alkaline conditions. So please remember exception. Every environment factor has exceptions. So that means so many environments can, microorganisms can survive over the leaf. And next important environmental factor is oxygen, especially the food poisoning or the purifications. So, can you live without oxygen? No, no. Yeah, but the many bacteria can live or can survive without oxygen. Please remember. So we can categorize four types microorganisms. One is aerobic bacteria. In Japanese, koukiseki. So cannot grow without oxygen. They require oxygen every time. So like the fungi, Bacillus subtilis, or like the Bacillus subtilis. And the second category is facultative anaerobic bacteria, Japanese called 通性嫌気性ですね。So can grow even with or without oxygen. And third category is strictly anaerobic bacteria, Japanese called 変性嫌気性。So can grow only when there is no oxygen or only a small amount. And the fourth one is microaerophilic bacteria, Japanese called 微好気性。So can grow when oxygen is present only a little. So these four categories. And these four categories bacteria closely related food poison. So that means oxygen exists, no problem. Oxygen not exist, no problem for decomposing food. So don't think only the human theories. So bacteria, microorganisms can survive or live everywhere, every condition. And the next environmental factor is osmotic pressure. So for the growth of microorganisms, a specific constant internal osmotic pressure is required for each microorganism. And internal osmotic pressure is kept higher than external osmotic pressures. Internal and external. So osmotic pressure resistance for microorganisms. So fungi is strongest. And bacteria. Bacteria is weakest during this three type of the microorganisms. And this word is also the technical terms. So hyperosmotic bacteria so require high osmotic pressure for growth. So such as halobacteria. In Japanese, koenkin. So high concentration of the salt. Salt lake, such as a salt lake, has a high concentration of sugar. Basically, almost all the microorganisms cannot grow. But some bacteria, this kind of hyperosmotic bacteria, can grow even in that kind of severe conditions. And the next factor is pressure, hydrostatic pressure. So general growth atmospheric pressure is appropriate. But bacteria can grow without trouble about several atmospheres. That means like the 10 atmosphere pressure condition or the 50 atmosphere pressure condition doesn't matter. So they can grow. And some bacteria, so this is also a technical term, malphilic bacteria, Japanese called koatsuei saiki. So Bacillus submarines grows well even at 600 atoms. That means 6,000 deep layer of the sea. They can grow. And also some bacteria eat bad tolerance. The Japanese called 耐圧性細菌。圧力にがあっても耐える。上の方は圧力が好き。圧力がないと生きていけないってやつですね。で、for example, Bacillus subtilis fungi is can grow at 400 to 600 atoms pressure. They can grow, they can divide, even at 40 degrees Celsius. So most microorganisms cannot tolerate sudden pressure change and burst. So, and this is not environment factors, but the classification of microorganisms based on energy and carbon source. So we can categorize 4 groups. So first one is hot autotrophic. Japanese 光合成独立栄養. So energy source is light, and the main carbon source is carbon dioxide, CO2. So this kind of the microorganisms belong. And the second category is photochemoautotrophic. Japanese 光合成、ヘテロトロフィック。ごめんなさい。光合成従属栄養。So energy source is light, but main carbon source is organic compound, not carbon dioxide. And third category is chemoautotrophic. Japanese called 化学合成独立栄養。So the energy source is chemical substance, and the main carbon source is CO2, carbon dioxide. Fourth one is chemoheterotrophic. This categories including Earth, human being. So 化学合成従属栄養。So energy source is chemical substance, and the main carbon source is organic compound. And basically, food poisoning or like the putrefaction is this category. Organic substance and converted to the second materials. So the influence of microorganisms on human activities, we can categorize like the 1, 2, 3, 4, 5. And so this lecture is focused on the food. So food preservation, fermented food, and food addict. And especially today's lecture related putrefaction and food poisoning. Yeah, of course, other like the agriculture, disease, energy and environment, and biotechnology. All the categories closely and strongly related or supported by microorganisms. But today, this lecture will focus on food. So food and microorganisms So microorganisms deeply related to food, especially bacteria, yeast, and mold, fungus, and virus. Microorganisms are important in food hygiene. And this section related bacteria and virus. Okay. So, what is different? I think you know the fermentation and putrefaction, Japanese 発酵 and腐敗. What is different? Both are related microorganisms. Yeah. So in a state in which microorganisms are decomposed for food components, fermentation and putrefaction is also the same. So food decomposed by microorganisms. So what is different? So fermentation is alcoholic fermentation is a type of anaerobic respiration in which sugar is changed into alcohol and carbon dioxide. And putrefaction, protein, amino acids, and so on, are decomposed to produce pleasant odors such as hydrogen sulfide and ammonia. However, it is sometimes called decay even in the decomposed state of sugar, and it is not distinguished by difference of raw materials or metabolic products. So, the most clear division way is fermentation to produce useful food for human being, for us. And the decomposition or putrefaction is to be decomposed into food that people cannot eat. So this is simple way. So basically, this it uses a human value standard. So this is very simple distinguished way. Fermentation and putrefaction or decomposition. So fermented food, I think you know, and every mother country has some fermentation food, such as yogurt and cheese, fermented milk with lactic acid bacteria. So every fermentation step related some bacteria, specific bacteria. So natto related plate Bacillus natto, and soy sauce and miso is aspergillus, yeast, and lactic acid bacteria. And Japanese fermented food, so many. There are many fermented food in Japan. So fortunately, fermentation and brewing science developed in Japan. So if you're interested, so please learn deeply in Japan. Our college also joined some teachers related to fermentations. Not me. I'm not the anaerobic bacteria is main target. So but the fermentation way is very, very important now. For example, making bioplastic. Yeah, very important role. So, and just I introduce you, you already the more about 20. So you can drink alcohol. So wine, beer, Japanese sake is all the fermented. Okay. But so they're different. So wine is a single fermentation. Beer is single line, multiple fermentation. Japanese sake is parallel multiple fermentation. So the more difficult to keep the conditions in Japanese sake making. So if you can drink the alcohol, please try Japanese sake. So, alternation of food by microorganisms. For example, biological food coexistence with microorganisms present in the environment at harvest. So back to the step by step, living or the attached microorganism species changing. That's very important. Not keeping or the stay the same microorganisms from the harvesting to the on the tables. So that was very, very important. At first, of course, coexistent bacteria. But then, doing decomposing, that means convert the first substance, original substance, to the different substance. Then, the condition or the construction of the food changing. Then, leaving the dominant microorganism species changing or shifting. And then food is decomposing. That step is basically normal step for the decomposing the food. So entry pathway of microorganisms into food. So fungi and bacteria are everywhere. I already told you. So attached to the object and carried, and they are carried on the air. So both attached from soil was attached from the air. Doesn't matter for microorganisms. So in case of fungi, it is carried in the state of spores. And here are two substances. Growth mycelium germinates and becomes fungus. And average 80 spores per cubic meters. So this rule having the, I'm not sure, 20 cubic meter or something. So that means 20 times 80. 1,600 spores surrounding these rooms, at least. So hygienic control requires not only a sanitary check, sterilization, and cleaning of the object itself, but also microorganisms in the space. That also important. So, what point we should check? We should mention. The important point I already told you. First one is temperature. So moderate temperature, 10 to 35 degrees Celsius, is very comfortable for microorganisms. in the food. And nutrients, so organic and inorganic substances, it's unfortunately everywhere in the food. Moisture, humidity is basically almost not all, but many food having the comfortable moisture for microorganisms. And fourth one is oxygen. So removing the oxygen completely is a little bit difficult. Yeah, of course, we have several ways to remove all the oxygen from the food. But sometimes it's very difficult. But this temperature, nutrients, moisture, and oxygen is four important factors, environment factors for the food microorganisms. And another definition, definitions. So putrefaction, I already introduced you, and spoilage. In Japanese, putrefaction, fuhai, and spoilage, hentai. So this is a different technical term. And generally, a phenomenon in which a food is altered by microorganisms to lose an edible part. There is a following change when it became putrid, change smell, taste change, gas produce, thick dust. So putrefaction is protein decomposition process in food, and spoilage is a carbohydrate and fat decomposition process. So this is a technical terms different. So putrefaction and spoilage is a little bit different. So putrefaction is mainly the protein decomposition, and spoilage is mainly the carbohydrate and fat decomposition. So the putrefaction continuous metabolic process leading to the final product via various intermediates. So early stage characteristics of food and storage conditions then occurring putrefactions. So basically, it's impossible to keep fresh forever, to keep good condition forever. So because everywhere microorganisms live, survive, even in the food. And if the characteristics changing by the microorganisms decomposing, then next environment condition favoring microorganisms growth, and then changing, and finally putrefaction. So not at first the fresh stage, and then putrefaction. No. So each step occurs in the food. So don't misunderstanding. And each steps worked different microorganisms. So how we preserve food? That's one of the important points of my lecture. I already told you the characteristics of microorganisms, not only the related food, but also the environment. So the method of storage can be roughly divided into two categories. First one is keep food at low temperature. So growth rate down and just sleeping. So not cell number increasing. Cell number increasing is sometimes very severe problem for the food. So keeping a small number cells is one way to preservation of food. So then a low temperature or the freeze or dry stage, removing usable water. So keeping the cell number small. As soil, acid, and preservative to suppress the growth of microorganisms in food. And the second way is inactivate microorganisms in food, such as heat, radiation with ultraviolet light, disinfectant, so on, seal them in the containers and prevent secondary contamination from the outside. Is also useful way to keep the food. The first method. So many thermal sterilization, ultraviolet sterilization, eradication of bacteria, chemical sterilization, refrigeration, freezing, and salting and sugaring, and drying, and vacuum packing, and smoked and picking in vinegar. So many ways, methods we already find out or establish to keep food safely. So each one having some characteristics. So please check later. Why we do like the salting, sugaring, or drying, or the smoking, or the picking in vinegars? Because removing free water from the food is very important. So in the food, water is a two-phase. One water phase is what phase of the forms. One is bound water combined with proteins and carbohydrate, and the other is free water. So not binding. Free water. So we code this free water is AW. So AW values is maximum 1 is 1.0. So 1.0 is like the raw meat, fresh fish, vegetables. And then decreasing, that means decreasing free water percentage in the food. Then like the 0.7. So 0.8 like the soy sauce, miso, jam, honey. there are not so many free water is in the this kind of the food. So such as the salting and sugaring something. So removing free water. And then growth bacteria or the microorganisms. So AW value is around 1.0. So many bacteria or the microorganisms can grow. But free water value decreasing, such as 0.8, only the general fungi or the halobacteria only survive as growing growth. And 0.7, so drought resistance fungi or the yeast only grows. So free water value is one important factor to keep food safety. But most important is here. Don't eat. Don't eat. Yeah, I show you this how storage the food. But most important is if the food is putrefied, so don't eat. You have eye, you have nose, so you can, you have finger, okay? So you can check food by yourself. So please believe your feeling. That's most important point. And then feel and something strange. Don't eat. Do you feel something strange? Don't eat. That sense is very, very important. The final section, I will introduce food poisoning. So unfortunately, every year happened many food poisoning accidents, not only in Japan, but also in the world. And almost all related microorganisms, unfortunately. So I will introduce some of the information in Japanese, in Japan. Okay. So I checked some data. So this is the occurrence of food poisoning in Japan from the 2019 to 2021. So the red color is 2019 and the blue color is 2021. So you can see the incident case, almost all is 1 to 10 patients per people's accident in Japan. So not so large number of people the accident occurred. And so this is the total number of the food poisoning in Japan. So 2019 is 1,330, but 2021 decreased 717. What? Right. So this is because coronavirus. So we didn't go out and we didn't take lunch or take a dinner, a restaurant, or many people gather. So this is why decreasing. And one more important information is this graph. So food poisoning basically occur warm season from July, June, July, August. I think you feel or that you think, but that is different, wrong. So this is every month accident number. Sorry, one is January, and 12. This is November. Sorry, December. So you can see every month almost the same accident number. So that means food poisoning occurred not only summer season, but also the winter season in Japan. I think this situation is basically same for the world now. So don't remember, not care only the summer season, but also the winter season is also you should care. And this graph showing the monthly incident of food poisoning, number of patients. Sorry, not patients. So this is caused what kind of the bacteria or the virus or the parasite occurred, happened, the food poisoning, 2019 to 2021. So you can see almost all patients is related, red and blue. Okay, red and blue is virus and bacteria. So in Japan, almost all food poisoning is related bacteria and virus. That's the real situation in Japan. And so what kind of the bacteria related to the poisoning? In Japan, almost all is Campylobacter. And if the patient numbers, that case, norovirus, adenovirus is very important. But in only the bacteria, so almost all is related to Campylobacter. That's a real Japanese situation. But gradually now decreasing related to the coronavirus effect. But I think from this year and next year, I suppose this graph will be increasing phase. Because now we can go out and we can meet together and eat together. So again, food poisoning occurs even in winter. So of course, if your mother country is a tropical region, doesn't matter. Every month you should care. But in same as Japan, you have the winter season, but should be care. Same as summer season. The occurrence of food poisoning increases from early summer to early autumn when temperatures rise, but it also occurs in winter. I already show you. So from the early summer to the early autumn, at a temperature suitable for increasing food poisoning bacteria, especially food poisoning caused by Vibrio, which occur by the eating seafood, is mostly occur in the summer. From the December to March, viral food poisoning, especially the norovirus, tend to occur in Japanese case. And now, not only the Vibrio, but also the Campylobacter is main pathogen for food poisoning in Japan. And I told you, keeping microorganism cell number small. Why? Because so the minimum infectious cell dose, Japanese called 最小発症菌量. So that means, so if we eat small number of the pathogenic bacteria, basically doesn't matter. Yeah, of course, if that bacteria produce some toxin, that case is no good. But and the other, so small number of bacteria also affected having the food poisoning. That case is we should consider. But so this table showing so the bacteria names and the minimum infectious cell dose. So for example, pathogenic E. coli O157. So this is very small numbers. So 10 powers 1 to the 10 powers 3. If you take E, you get food poisoning. But for example, Bacillus cereus. So in this case, 10 powers 5 to 10 powers 7 is minimum infectious cell dose. So it's completely different, or the different orders. The minimum one is like the Bacillus Brenshetterium, Securicin 10 powers 1. Also the Salmonella is 10 powers 0. That means one cell, only one cell. If you eat, you catch. Sometimes you catch food poison. Also the pathogen B. coli, some specific species, like the O157, 10 powers 1 to 10 powers 3. Very small cell numbers, if you take, you may food poison. So from this information, so we should keep, keep or save cell growth in or on food is very important. So keeping cool or the cold temperature, I require. And also, this is the living cell numbers. Okay? So, killing cell is also very important. If the cell died, doesn't matter, basically. Yeah, of course, like some toxin producing. After toxin producing, it's no meaning to heat. But if taking cells in the body, that case, killing bacteria is very useful way to protect food poisoning. So please remember this infectious cell dose. And heating is most important when you cook food. So this is the information of the death temperature or time and the minimum growth temperature of typical food poisoning bacteria. So you can see required more than 60 degrees Celsius and more than 1 minute to kill bacteria, to poisoning bacteria. Okay? So this is the minimum. So I strongly require you when you cook. So keeping more than 75 or 80 degrees Celsius and keeping at least 3 minutes to 5 minutes. Yeah, of course, more high temperature is more better, I think. Also, so minimum gross temperature less than 10 degrees Celsius and main almost less than the 5 degrees Celsius. So that means your refrigerator temperature setting should keep less below 5 degrees Celsius. Or more good condition is around 0. That means 2 or 3 degrees Celsius is more efficient for the keeping or sleeping bacteria, not growth. So please remember this information. And so I will introduce you the two pathogen food poisoning caused bacteria and virus. So one is the Campylobacter. I already introduced you. So this kind of the symptoms. And the important point is the cold food. Basically the chicken, animal meat, and well water. So don't drink raw water. So please boil before drink. That requires strongly. Yeah, that's one important point. And so the next important one is norovirus, so adenovirus. So basically cold food is shellfish, especially raw oysters. Yeah, but now this information misleading. So of course, yeah, raw oyster accumulate adenovirus, but basically not so important cause food. So now so spread norovirus. So I'm not sure. I think not only the oysters, but also other some living organisms produce norovirus. Also, not only the animal living organisms, but also the human being. I think 50% or more is related to human being, I suppose. So norovirus food poisoning, if happened, so huge number of the patients. So not 1 to 10. So sometimes more than 500 people is food poisoning by norovirus. So patient number rapidly increased by one accident. That are completely different situations. Compare than other microorganisms or natural toxins. So, almost conclusion of my lectures. So, three principles of food poisoning prevention. So, basically, I already told you. So, first one, don't attach pathogens. And the second one, don't increase number of pathogens. And third one, kill pathogen. So this 3 point is very, very important for food poisoning prevention. So don't attach pathogen. Don't increase pathogen. And kill them. So this 3 step is very important. So remember these 3 points. So today's my lecture related like the water and food. Basically, that including the environment. So and now situation in the world and the earth. So we should consider or think about environment, of course, for such as global warming or biodiversity loss and so on. But only considering environment. So doesn't matter, not considering energy and not considering economy. So if the keeping good environment, that's very simple resolution. Okay. Don't use electric power. Don't eat 3 times every day, only 1 time. Don't eat cow or some animals. Don't move by car. Don't use oil. Is it okay? It's impossible now. Okay? So that means we should consider not only environment, but also the energy and the economy. So don't use money. Don't move any fear. So no economy. It's very simple way to keep the environment. And finally, yeah, we cannot live on the earth. The most problem is humans. But it's impossible. So we should consider not only environment, but also the energy and the economy. So these 3 categories, materials are related together. So this kind of the triangle relationship, we called polylemma problems. So this relationship have 3 parameters. So that case, it's very difficult to get best answer. because the parameter is 3. But I think we can get better answer. So now, in your age, equally, how to get better answer to resolve this trilemma problems. And after today's lecture, not only this trilemma's problem, but also the water and food is also very important, of course. So please consider, think about this, how to resolve this very difficult problem in near future. Okay, so that's all my lectures. Is there any question? So Taiwan side, can you understanding my English and my slide?
Yeah. Yes, yes.
Thank you. 質問ありますか？いいですか？ちょっと早いですけど、まあ、こんなもんでしょう。はい。じゃあ終わります。お疲れ様でした。じゃあ、俺退出していい？
はい、それでは
ありがとうございました。はい、私のなんか言った方がいい。